Hello everyone, my name is Sanket Dange from TY Electrical Road number 16. Today I am going to explain you about the modeling and simulation of electromechanical system using block diagram and transfer function, which is a electromechanical analogy. So there are four group members who are presenting this topic. First one is Bhakti Chavan, second Yash Chavan, that third one is me Sanket Dange, and fourth one is Ayush Gore. So let's start with the index. In this introduction, we in this presentation we are going to see about the introduction about the electromechanical analogy of block diagram simulation. Next is the simulation block diagram. Third one is simulation results. Next, advantages, disadvantages, application, conclusion, and references used in this presentation. So let's start with the introduction. Firstly, an electromechanical system is a system that integrates electrical and mechanical components to inform a specific function. These systems convert electrical energy into mechanical motion or vice versa. Next is one of the most common and widely used electromechanical system is the DC motor, which converts electrical energy into rotational mechanical energy. Next is DC motor are extensively used in applications such as electrical vehicles, robotics, industrial machines, and household appliances due to their simple control and high efficiency. So, to understand and predict the behavior of such a systems, mathematical modeling and simulation are essential tools. They help in analyzing system performance without physical building the system. In this project, a DC motor with load is modeled using transfer function and a block diagram representation, which allows us to study system dynamics like speed, torque, and response over time. Uh, Simulation tools that we have used in this simulation is such that MATLAB Simulink are used to visualize and evaluate the performance of the system under different conditions. Next, the block diagram will be explained by Yash Chavan.
Hello everyone, I am S7 from TY Electrical and I am explaining the simulation of block diagram. This is our block diagram. First we require the armature voltage. We give the 220 volt input voltage. This is the supply to the DC motor. Then we require the sum block for voltage equation. It subtract the back EMF from the input voltage. Then we require the transfer function. It is the electrical part. It represents the armature circuit. Then we require the gain KT. It is the torque constant. It converts the current into torque. Then we require the sum to block for mechanical equation. It combines the torque and load effect. Then we require the transfer function for the mechanical part. It represents the motor dynamics. Then we require the integrator. It converts speed into the position. Then we required one constant block. We give the 100 voltage to the constant and it is connected to the sum 2 for mechanical equation. Then we required the uh, gain KB. Gain KB is the back EMF feedback and it converts speed into the feedback through the KB. Then we required one scope for the output. Then we connect two display to the scope, one for the speed of the DC motor and another one is for the distance of the DC motor. Then it is our first graph for distance response of the DC motor. Then it is the second graph for the speed response of the DC motor.
Hello, sir. This is our simulation model. This is the armature voltage, which is 220 volt. Then summation block transfer function 1. Then KT and KD are the constants. Then summation block 2 transfer function 2. And then integrated converter. These are the scope for observing the output and sorry. These are the display and this is the scope for waveform observation. Now we see the how it will be connection diagram. Then armature voltage to summation block, then summation block to transfer function, then transfer function to KT, then another one summation block. Now output of summation is given to transfer function 2, uh, and then it will be integrate using integrator converter. Now this is the gain KB and this is the feedback path for KB to summation block 1. See, this is the first output which is given to scope. Integrator's output at first point, and then display 1 and display 2. Display 1 shows the DC motor speed up, and second one is the distance of DC motor. Now we will run this simulation. Speed of DC motor is 195.4 and distance of DC motor is 2146. Let's observe the waveform. These are the two waveform which was given by that simulation. Thank you. Next, this simulation waveform will be explained by Bhakti.
Myself Bhakti Chavan from TY Electrical, roll number 13. Today I am going to explain the output waveform of the DC motor. We can get the waveform from the scope. So here is the two waveforms are observed. First, it is the distance speed of the DC motor, and second one is the speed response of the DC motor. Firstly, I am going to explain about the speed response for the DC motor. So at the starting condition, we can say that the speed increase is very fast. This happens because of the input voltage is applied and there is the zero back EMF. As the speed increases, the back EMF is also increases, which reduces the effective voltage. After some time, it becomes the stable and reach at the stable condition near about the 195 radian per second. Next is distance response of the DC motor. We can say that it continuously increases in the straight line and it reaches to the stable condition. Thank you.
So the advantages of this system is first advantage is easy analysis of complex system. Second advantage is helps predict system behavior. Second is to reduces the need for physical prototypes. And fourth one is the time and cost. It is very time and cost efficient. And the next, there are disadvantages of this system. There are some disadvantages. First is depends on accuracy of model. This model is not that much accurate that we cannot fully depend on this model to get the accurate values. So next is simplification may cause error. To make this application, this simulation to more simplified, more understandable, it causes some errors, requires software knowledge and computational limitations are there. Next, there are some applications of this motors. First is electrical vehicles. For electrical vehicles, we need a specific speed, specific torque should be generated at the starting of the motor. Next one is in robotics. For robotics, like a robotics arm or any robotic applications, we need specific and constant speed and minimum or maximum torque as per the application. Next is industrial automation, conveyor system, and CNC machines. These all are the applications of our model. Summary of the model processing, summary of modeling and simulation process. It is very costly.
From our topic, we can get the conclusion that the DC motor achieves the stable speed and the uniform motion due to the feedback and the load balance. Thank you.